Big data customer, many industry domains. I will talk about big data customers or industry domains. Had a look at 4 V's of big data: velocity, volume, variety, and veracity. And the problem domain big data trying to solve or trying to push challenges upon us, right? Two big data problems that it trying to push upon us. One was the storage. As the data increases, we need to arrive at better way to storage. And one was the processing complexity. These are the two major potential problems at the big data domain. And any system that is trying to answer the issues of big data have to solve these two problems, right? So given that these two problems can be solved using 4 attributes: volume, velocity, variety, and veracity. And if you want to implement a system, you need to ensure that some of the V's are added to here. Right? Big data to be used in variety of domains, right from retail to industries to finance to telecommunication, even to prevent crime, even to predict crime, and to have predictive modeling done and to make business decisions. It's not just used for e-commerce as everybody perceives, that it's used in variety of domains, even in healthcare also. It could also be desired to identify business risk, security. Is this person going to defaulter on loan? Predict new business opportunities, compile regularity laws, security laws, transaction laws, financial laws. So this is lot of reason for getting into data analysis. Why it is big data? Why it's so prevalent today? Was data not been available in 30 years? Or was it just available in today's world that we are trying to deal with this data? The answer is that data has been there. Data has been prevalently since 30 years and data was always structured. When we try to deal with it, that how we always have been the data, but the statistics indicate 70 to 80% of the data in the real world in day-to-day life goes unstructured or semi-structured. For example, go out on the street, we talk to people. Then you say, "Hi, how are you? How are you doing today?" Or "Hello." I mean, is there any specific format? Going back to the use cases we are taking about, so primarily 70 to 80% of the data in the present world is unstructured. We don't have a specific structured way of talking. We have a casual way of talking to friends. We have a casual way of talking to families. We have a casual way of talking to strangers. We have some formal way to talking to people. But are we dealing with a structured way of data in real life? That answer is no. It's mostly unstructured, mixed with structured at times. So if this is the case, why can't we exploit such unstructured data into things that will make more meaningful sense to us? That's the question we got here, which is why traditionally when we're dealing with data, we always dealt structuring the data and putting them into right format, right data type, right fields, things like that. But in today's world, we don't really bothered about the format. We bothered about capturing the data. We bothered about format when we come at the later stage while we're dealing with the data. So given that most of the data in today's world that we see is being used by very many industrial domains, such as web and e-commerce website. We have famous e-commerce websites like Alibaba, Amazon, Snapdeal, Flipkart, eBay, Walmart. There are many websites which are using big data. How they are using big data? They are making recommendation engines, ad targeting, search quality, abuse and click fraud detection, based new customer prospects, sales pricing, profitability, etc. They are checking using the big data. What now? I mean in telecommunication. Telecommunication is one of the biggest The other industry we were talking about which has more prevalent application of big data in telecommunication. Why telecommunication? Because we make calls in day-to-day life. We make WhatsApp messages in day or day out. We use data, we use SMS. So we need to predict the usage pattern of calls. Need to predict the usage pattern of messages. And we need to predict the signal strength and the network presence of this mobile network provider to give the better services to people, to give better services to us, and to provide more applications so that we can use network in more appropriate and effective manner. So these are the companies which are using big data in telecommunication sector. Now the interesting thing is, government also employs big data. To give the example, Aadhaar of Government of India is one of the biggest big data implementation called. Do you know why? Because Aadhaar holds the largest database of Indian population. Secondly, for Aadhaar, so many parametrics have been collected. Not just the name and age of the person, but also the biometrics and fingerprints have been also collected. And top of it, handling the Aadhaar system is more challenging because too many people queuing and get an Aadhaar card at a shorter amount of time. So it is short of satisfying dealing with volume, variety and velocity. Which is why Aadhaar is one of the most touted big data implementation in the world, and India is one of the proud implementer of big data. I'm gonna ask you a question. What if Aadhaar is implemented as centralized database storage? Do you think that it works? What if we design to have Aadhaar database as centralized database storage instead of distributed one? So problem with having too much of data at one place is, what if the place is compromised? What if the data that is stored in the server, which is one single server, is compromised in terms of physical attacks? Let's say by our enemies or some sort of natural calamity that happens, then eventually we lose the information of all the citizens of India. Right? That's number one. Number two problem can be really, probably, practically build a computer that hosts 1.2 billion records of X amount of size to represent the citizen information that's going to be nearly impossible. And the third problem is, even if we manage build such computer, because we have mainframes, we have built mainframes in the past, the Big Brother and Big Blue computers, which could store like this, which can perform trillions of transactions per second, but with given a real estate, how much of space would you need to host a such computer? And also consider the power and air conditioning that we would need to power the unit and keep the unit in healthy maintenance state. Don't we say there is problem evident for us? Putting all the data in one computer is not going to be as easy way. That's how we have been traditional computing, isn't it? Obviously, Indian government, when decided to implement this big data thing, they went Hadoop way. So let's say if we in India, we have states, let's say we have 4 states. And if you want to fetch the demographic information of, let's say, one of the states like Delhi, you only do the processing of Delhi cluster and not anywhere else. So Aadhaar implemented them in big data way by using Hadoop cluster. And now switching to the other use cases here, there is something interesting to note. Government also adopt big data analytics to do the crime prevention also. How do you think crime prevention? How do we prevent crime if you are the cabinet secretary and you are given task to prevent crime from social media networks? How would you go? Simply speaking, we try and monitor the social networking site to find relevant information that possibly cause some sort of communal violence or a riot or any sort of disturbance to the community, and you flag them to prevent the crime. I mean, this idea is not new. This idea was existing in years ago. In today's world, we have big data, data that is put by us. So we used to save data, we analyze them and then predict the crime that going to happen in period of time and then government prevent the crime. So this is the lot of reason for getting into the data analytics. And we also find big data applications in healthcare and life science domain, majorly into insurance, drug safety and service quality improvements. In the last few years, there has been a move towards evidence-based medicine, which involves making use of all the clinical data available and factoring that into the clinical and advanced analytics. The outcome of this movement include improved ability to detect and diagnose disease in their early stages, assigning more effective therapies based on the patient's genetic makeups, and adjusting drug dose to minimizing side effects and improve effectiveness. Stony Brook Medicine uses the big data analytics. And the next sector is banking and finance services. One more example I can give you is Progressive. Look at the way they are changing their business model. When we actually got insurance, we have insurance, we typically say auto insurance will pay $600 a year or $300 for every 6 months. And how they determine this rate? Your age, your gender, are you married or not? They have all these different calculations, information about you and then say, okay, you are fit in this bucket. They never ask me like how many tickets I get, right? But the reality is, it would be nice to have how fast do I drive, what is my normal behavior. So they have installed small devices in our car and now they can actually track every minute you drive. They know how many miles you drive. Usually they ask you how many miles you drive a day, right? You could lie. Now they know exactly how many miles you driving, right? So it's almost like they can offer a customized product to you. This is what I mean saying. Even the reason this is becoming interesting is because by doing analytics, now you can actually offer different services, new features to your customers. Banks also analyze your credit scoring and according to that they are providing two loans to you. And in the retail sector we have one of the biggest implementer of big data is Sears company. This is all about big data customers and the sector in which we are using big data analytics.